We also have where you have polynomials that have a higher power than 3, that you can use this same process. You have to do a little bit more work though because the degree is higher. Okay, so what happens is that you either have to synthetically divide twice, or you can see if you can factor and go from there. So let me show you by synthetically dividing. So if we look at this one, I'm going to start with my p over q. So again, the constant is p, the leading coefficient is q, so I'm going to have p over q is plus or minus 1 and 5 over plus or minus 1 and 2. So I get 1 and 5 divided by 1 is just 1 and 5. 1 and 5 divided by 2 is a half and 5 halves. Okay. So I can go put this in my calculator. I'm going to use Desmos this time. It's already put it in mine. So notice I can click here and I can see what my x-intercepts are. So I have one at 1 and one at -1. So I pick one of those to synthetically divide by. It doesn't matter which one. If you pick a different one than mine, your work's going to look slightly different. I'm going to synthetically divide by 1. Now I check here, I've missed powers. I missed cubed and an x. So we have 2, 0, 3, 0, -5, because we've got 4, 3, 2, 1, none. So I bring down the 2. That gives me 2. 0 plus 2 is 2. 2 times 1 is 2. 2 plus 3 is 5. 5 times 1 is 5. 0 plus 5 is 5. 5 times 1 is 5. -5 plus 5 is nothing. All right. And now if this was a 4th power, that means that this gets knocked down to a cubed. Which, notice we've got cube squared, 1, none, and then our remainder. So what happens is I can't do anything with this based on what we know. But we can go back and look at our graph and notice we have another x-intercept of -1. So we had synthetically divided by 1. Yes, 1. Just want to make sure I hadn't done the wrong one. So we synthetically divided by 1. So now we need to divide by another root or an x-intercept or solution. Okay? Now, if at 1, 0, if it had bounced at 1, 0, that means that it has a multiplicity of 2 or 4 or some even powered multiplicity, which means I could synthetically divide by that number again. However, it's not bouncing at this one, so I have to pick a different x-intercept. So here, I'm going to pick the x-intercept of -1. Now notice both 1 and -1 are on our list of possible rational zeros. So instead of synthetically dividing this one by -1, which would also knock it down to a cube power, what I'm going to do is I'm going to take the leftover polynomial and divide that by a -1. So I'm just going to add another thing here and do a -1 here. So I bring down the 2. So -1 times 2 is -2. 2 plus -2 is nothing. -1 times 0 is 0. 5 plus 0 is 5. -1 times 5 is -5. -5 plus 5 is nothing, nothing, nothing. So when you do it a second time, you need 2 zeros in order for it to be a root. So notice when this was a cubed, we knocked it down 1, so this one will be a squared. So squared, 1, none, and then this is our remainder. This 0 is our remainder for this one. Okay? So that means that my polynomial that's left is 2x squared plus 5. Right? Now I can use the quadratic formula to solve this. So I would have that a is 2, b is nothing, and c is 5. So I would have x equals -b, which is 0, plus or minus the square root of 0 squared minus 4 times a, which is 2, times c, which is 5, all over 2 times a, which is 2. So I get 0 plus or minus, and then 4 times 2 is 8, times 5 is -40, all over 4. Well, 40 is really 4 times 10. This is 2 and 2, this is 2 and 5. So I have a pair of 2's that comes out, an I that comes out since it's a root that's negative, and then the 2 and 5 stay underneath, and that's all over 4. And I still have this plus or minus. Whoops. Still have this plus or minus. So the 2's reduce, so I get plus or minus I root 10 over 2. Now, you also could have, from this point right here, you could have solved using the square root property. So here, if I subtract the 5, I get 2x squared equals -5. And then I do divide by 2. So then we get x squared is plus or minus, not plus or minus yet, x equals negative 5 halves. And then I take the square root of that. So here, if I take the square root of that, now I do the plus or minus. So x equals plus or minus negative 5 halves. But if I have a fraction under a root, that's really the same thing as this. I need to times by the root on top and bottom, so I get rid of the root on the bottom. So I get negative, plus or minus rather, negative square root of negative 10 over 2. And then I have to take out the I, so plus or minus I root 10 over 2, which notice is the same exact answer that we got here. So either way we do it, we get those x-intercepts. Now, if we list our x-intercepts, we have x equals 1 and negative 1, because these were our x-intercepts from synthetically dividing. And then we also have to list our ones that we got either from the quadratic formula or from solving with the square root property. So plus or minus I root 10 over 2. Okay. So all 4 of these are our x-intercepts. Notice 1, 2, 3, 4, 1 for plus and minus, which gives us the degree, which is 4. Okay. So let's take a look at this next one. So here we've got, this is P, this is Q, so P over Q is really plus or minus 1, 2, 3, 6 over plus or minus 1, 2, which gives us 1, 2, 3, 6 divided by 1, which is 1, 2, 3, 6, and then 1, 2, 3, and 6 divided by 2, so 1 half, 2 halves, which is 1, 3 halves, which I don't have, 6 halves, which is 3, which I already have. So all of these options. Okay. So then we have negative 2, negative 4. Oh, also this should have been cubed. Plus 8, plus 4, minus 6. Okay, so if we go to our calculator, we're going to have negative 2x to the 4th minus 4x to the 3rd plus 8x to the 2nd plus 4x minus 6. Okay. So then if I look at my x-intercepts, so I've got these ones that we have. So I have 1. Notice all of those are on my P over Q list. So 1, negative 1, and 3. So we've got 1, negative 1, and 3. Those are all on my P over Q list. So I'm going to synthetically divide by 1. Okay. So if I synthetically divide by 1, I've got negative 2, negative 4, 8, 4, negative 6. Bring down the negative 2, that gives us negative 2. Negative 4 plus negative 2 is negative 6. 1 times negative 6 is negative 6. 8 plus negative 6 is 2. 1 times 2 is 2. 4 plus 2 is 6. 1 times 6 is 6. Negative 6 plus 6 is nothing. But this just goes to a cubed power. So if we go back and we look at our picture, notice this x-intercept bounces. So that means that there's a multiplicity of 2 here. So I can synthetically divide by that number again. So if I synthetically divide by 1, I'm going to bring down the negative 2. Yeah, there we go. So 1 times negative 2. Actually, I should probably just squeeze it in smaller. So synthetically divide by 1. So we bring down the negative 2. Negative 2 times 1 is negative 2. That gives us negative 8. That gives us negative 8. That gives us 6. Sorry, negative 6. That gives us negative 6, which is 0, 0, 0. Okay. So this was a cube, so this knocks it down to a squared. And then our numbers show our leftover polynomial is minus 2x squared minus 8x minus 6. Okay. If I look, I've got a common factor of 2, so I can take that out. So x squared plus 4x plus minus 3. Nope, plus 3 because we changed the sign because we took out the negative. So then I say, okay, can I multiply to 3 and add to 4? Yeah, with 3 and 1. So x plus 3, x plus 1 equals 0. So I get x equals negative 3, negative 1. But also, don't forget your 1s from here. And that one has a multiplicity of 2. So these are our x-intercepts. Now, had you decided, so say you synthetically divided by 1, and then you synthetically divided by -1, what you got here when you factored, you would have got an additional 1. So you would have 1 from synthetically dividing and then 1 from factoring, so it would have a multiplicity of 2. So that's how you find your zeros using the P over Q and your calculator with synthetic division and either factoring or your quadratic formula.